Hello and welcome to the second part of our calculator tutorial. So, the last part we did the sum and subtraction of two numbers. Now let's do the division and multiplication. And we will start adding the option for the user to choose different kind of operations. So let's start with the following. If we want to do a simple multiplication between both numbers, it's as simple as putting num1 by num2. While division is as simple as putting num1 divided by num2. Now, let's see what happens when I do this. Okay, if I execute, wait, I just forgot to print the, you can always stop the app here on the left and then execute it again from here if you want. I forgot to print them. Okay, so let's put two more print ln's so we can see the results also of the multiplication and the division. Mult and div. Okay, great. So now we have all the operation on the two numbers we're going to enter. So let's try 125. You know that 125, 100 plus 25, 125, 100 minus 25 is 75, 100 by 25 is 2,500, perfect, and 100 divided by 25 is 4. Now I want to try another thing. Let's try it again here, and let's put some other numbers. Let's put 10 and 4. Okay, so 10 and 4 is great. 10 plus 4, 14. 10 minus 4, 6. 10 by 4, 40. 10 divided by 4, what is this? This is not right, right? So here it is, the point. We will make a small fix to make this work well, but here is one of the points I wanted to stop in. Okay, because we are using ints, which are non-decimal numbers, they are numbers that have no decimal part. What the system does when it detects that is, if you're trying to divide a natural, it's called a natural number, yes, you cannot, it will try to get to the natural division result, okay, without decimals. So if we divide 10 by 4, yeah, it's like it really equals to 2 point something. What it does, it doesn't show the rest, the decimal part. It only shows the division part, okay? It doesn't show the module. So if we want to show a decimal here, we have a number of options, okay? We can start by, instead of defining the numbers as int, we can define them as, for example, double. But now it will tell me, okay, listen, if you define it by double, you have to put the right declaration here. You have to 0.0. You have to add the point, okay? And here you have to change it instead of to int to double, okay? Same down here. And now we will have the results with all the results will be with decimals, but at least we will be able to see the decimal part of the division. 10, 4. Now it will show us 10.0 plus 4.0 is 14.0. 10.0 minus 4.0 is 6.0. 10.0 by 4.0 is 40.0, and 10.0 divided by 4.0 it's 2.5, which is what we didn't see before. We couldn't see this part because they were ints. So it's very important to remember that sometimes it is interesting to see only the dividing, the natural side of the division, or not without any decimals. Sometimes it's interesting to see it with decimals. I can tell you that for optimization, from a operational point of view, floats and doubles require much more memory and much more processing power than natural numbers, non-decimal numbers. So if you can exist, if you can try to avoid, that's the word, if you can avoid the use of double and float, it's always better. It's always better. There are cases that you cannot, but in this case, if you can, it's better. Okay, great. Let's add some complexity to the mix. Okay, we want to start the option, to give the option to choose one of the operations, and not to do all of them together and show them down there. Okay, so what we will do, just after these lines here, we will add conditions and flow control to choose which operation to do and what to show. And to do that, we will add a new variable up here that's going to be called var operator. That's going to be of type int, and initially it's going to be a 0. We will decide that operator, will represent the type of operation that we want to execute. Operator 0 will be the sum. Operator 1 will be the subtraction. Operator 2 will be the multiplication, and operator 3 will be division. So if I ask the user to choose to choose between different kind of operations, we will add a small menu, and the menu will look like this. We will first imprint a menu where we tell the user to choose one of the following options. Okay, let's put it like this. Please choose the number of the operation you want to execute. So then we'll print 4 options here. 1, add. 2, subtract. 3, multiply. 4, divide. Divide. So those are 4 options that we will have to read which one the user chooses by doing a read line as well, with the only difference that instead of doing to double, we'll do it to read line. Yes, we will. It will be equal operator equals to read line to int, because we want to turn it into an integer. Yeah. Again, we have to put these 2 exclamations. Now this will store one of these options, 1, 2, 3, or 4, and now we'll use source control, flow control with conditions if else to see which of the operators is it. If it's operator 1, we will execute this line here, and we will put it and we will print it like this. If its operator equals 2, we will do this line here, and we will do it like this. If the operator equals 3, we will do it like this, and we'll multiply it. If the operator equals 4, We'll do it like this. And we will divide it. Okay, so as you can see, I added the if option depending on the value that the user will enter from this menu, 1, 2, 3, or 4. Now we execute, and you will see that the first thing it does is asking for the first number. Let's put 40. Second number, let's put 13. Okay, and now he asks me, okay, what option do you want? Please choose the number of the operation you want to execute. 1 to add, 2 to subtract, 3 to multiply, 4 to divide. So let's say I want to subtract. Okay, so a subtraction will be 40 minus 13. And it tells me 40 minus 13 is 27. Finished. It doesn't do the other things because you already execute this line here, and then it jumps to the end because these conditions do not comply. Only this one, because operator is equals to 2. See? That's how we use conditions to jump different parts of codes if we don't want to do everything. That's something that in assembly we did with jumping to lines. Here we don't have to jump anywhere. We just have to put a condition for different blocks of code. The blocks start always with this and closes with this. And everything that is found inside the block will be executed only if this condition is true. If it's false, it will not comply and it will not execute. Like it's happening, because if I put 2, this will not execute, this will, this not, and this not. And with this, we added source control, flow control to our program, to our calculation.